Hello everyone, welcome first year students English section, Faculty of Commerce at City University. This is Reem Sabhi. I am a teaching assistant at Insurance, Statistics and Mathematics Department. This is section 4 in pure mathematics course on chapter 1 titled Relations and Functions. In this section, we will continue our learning objectives by testing the symmetry of the function with respect to axes. Testing for symmetry with respect to the axis. We have three cases. First, testing the symmetry with respect to x-axis. The equation is symmetric with respect to x-axis if the value of the equation is unchanged by replacing the value of y with negative y. So in the original equation we have to change the value of y with or replace the value of y with negative y. By doing this step, if the value of the equation unchanged, so this function is symmetric with respect to x-axis. As you see here in the graph, this function is symmetric with respect to x-axis. The second test is to test the symmetry with respect to y-axis. For testing this symmetry, the equation is symmetric with respect to y-axis if the value of the equation is unchanged by replacing x with negative x. So in the original equation, we will replace the value of all x's with negative x. And if the value of the equation unchanged and equivalent to the original one, so this is symmetric with respect to y, as you see in the following graph. This is the shape of symmetry. The third test is testing the symmetry with respect to the origin. The equation is symmetry with respect to the origin if the value of equation is unchanged by replacing y with negative y and x with negative x. So in the equation, we will replace all the value of y with negative y and all the value of x's with negative x, and if the value of the equation is equivalent to the original one, so this function is equivalent to the origin, as you see in the following graph. And when testing the symmetry, we get 5 possibilities. First, the function is not symmetry at all, or symmetry with respect to x-axis, or symmetry with respect to y-axis, or symmetry with respect to the origin, or symmetry with respect to x-axis and y-axis and the origin. Example. Test the symmetry of the following equation with respect to x-axis and y-axis and the origin. Question 1. The graph of the equation y equals to x squared plus 1 is symmetric with respect to. First, we have to test with respect to x-axis. And this by replacing all the value of y with negative y. So negative y equals x squared plus 5, and by multiplying both sides by negative 1, as we just need y, we get negative x squared minus 1, and this is not equivalent to the original equation, so the function or the equation of the graph is not symmetric with respect to x-axis. The second test is with respect to y-axis, and this by replacing the value of x with negative x. So y equals negative x squared plus 1, which equals to x squared plus 1, and this equivalent to the original equation. So the equation is symmetric with respect to y-axis. Let's test for the origin. and this by replacing y with negative y and x with negative x. So we get here negative y equals to negative x squared plus 1. So negative y equals to x squared plus 1. But here we just need y, so multiply both sides by -1. We get y equals to minus x squared minus 1, and this is not equivalent to the original equation. So by solving the equation, or by testing the equation algebraically, we find that the equation or the graph is symmetric with respect to y-axis only, and the correct answer is B. Question 2. The graph of the equation x equals y squared plus 4 is symmetric with respect to. We have to test this equation algebraically. First, for the x-axis. So x equals negative y squared plus 4. And this equals to x y squared plus 4, and this is equivalent to the original equation, so this is symmetric with respect to x-axis. Again, for the y-axis, and in the y-axis we change the value of all x's with negative x. So negative x equals y squared plus 4. And this is not equivalent to the original equation, so this is not symmetry with respect to y. The third test is with the origin, and this by replacing the value of y with negative y and value of x with negative x. So negative x equals negative y squared plus 4. So negative x equals y squared plus 4, and this is not equivalent to the original equation, so this graph or this function is symmetric with respect to x-axis, and the correct answer is A. Question 3. The graph of the equation x equals 2y squared plus 3 is symmetric with respect to. First, for the x-axis, and here we would replace the value of y with negative y. So x equals 2 times negative y squared plus 3, and this equals to x equals to 2y squared plus 3, and this equivalent to the original equation. So this is symmetric with respect to x-axis. Again, for the y-axis, and here by replacing the value of x with negative x. So negative x equals 2y squared plus 3. And as you see, this is not equivalent to the original equation, and which means this is not symmetric with respect to y. The third test with respect to the origin, and by replacing the value of y with negative y and the value of x with negative x. So negative x equals 2 negative y squared plus 3. Negative x equals 2y plus 3. Also, this is not equivalent to the original equation, so this function is symmetric with respect to x-axis only, and the correct answer is A. Question 4. The graph of the equation y equals x power 3 plus x is symmetric with respect to. First, let's test x-axis, and this by replacing the value of y with negative y. So negative y equals x power 3 plus x, but we only need the value of y, not negative y. So by multiplying both sides with negative 1, we get y equals negative x power 3 negative x, and this is not equivalent to the original equation, so this is not symmetric with respect to x-axis. Again, for the y-axis, and these by replacing the value of x with negative x. So y equals negative x power 3 plus negative x, and this equals to negative x power 3 negative x, and this is not equivalent to the original equation. The third test is for the origin, and this by replacing the value of y with negative y and the value of x with negative x. So negative y equals minus x square minus x power 3 minus x, and by multiplying both sides with negative 1, we get y equals x power 3 plus x, which equals to the original equation. So this function is symmetric with respect to the origin, and the correct answer is C. Question 5. The graph of the equation x squared minus y squared equals 100 is symmetric with respect to, first for the x-axis, and here by replacing again the value of y with negative y. So this equals to x squared minus negative y squared equals 100. So x squared minus y squared equals 100, and this is the same or equivalent of the original equation. So this is symmetric with respect to x-axis. Again, for the y-axis, and this by replacing the value of x with negative x. So negative x squared minus y squared equals 100. So x squared minus y squared equals 100, and this is equivalent to the original equation. So this is symmetric with respect to y-axis also. The third one is with respect to origin, and these by replacing the value of y with negative y and value of x with negative x. So negative x squared minus negative y squared equals 100. So this is equals to x squared minus y squared equals 100, and this is also equivalent to the original equation. So this is symmetric to the origin. So this function is symmetric with respect to x-axis and y-axis and the origin, and this the correct answer is D. The graph of the equation y equals 9 minus 4x squared is symmetric with respect to, again, for the x-axis, negative y equals 9 minus 4x squared, and by multiplying both sides by minus 1, we get y equals minus 9 plus 4x squared, and this is not equivalent to the original equation. So this is not symmetric with respect to x-axis. The second one for the y-axis, and these by replacing the value of x with negative x. So y equals 9 minus 4 times negative x squared, which equals to 9 minus 4x squared, and this is equivalent to the original equation. So this function or this equation is symmetric with respect to y-axis. For the origin, by substituting the value of y with negative y and the x with negative x, we get negative y equals 9 minus 4x squared. By multiplying both sides with negative 1 in order to only get the value of y plus 4x squared, and this is not equivalent to the original equation, so this function is symmetry with respect to y-axis only, and the correct answer is B. Question 7. The following graph is symmetric with respect to x-axis, y-axis to the origin, or to x and y and the origin. By taking a look here on the points on the graph, we can see that each point on the upper side of the graph have the opposite value or the negative value on the other side of the graph. So for the first ordered pairs 3 and 3, we can see that we have on the other side negative 3 and negative 3. And for 2 and 2, we can see that we have the opposite values, negative 3 and negative 2 and negative 2 on the other side of the graph. So this graph is symmetric with respect to the origin. And the correct answer is C. Again, for this graph, we can take different points, and here for this point, which is 3 and 2, we can look for the opposite value of these points, and we can find 3 and minus 2, and this means that this graph is symmetric with respect to the x-axis, and the correct answer is A. For this graph, we have a point here 1 and 1, and the opposite value of this point on the other side of the graph is negative 1 and negative 1, and this means that this function is symmetric with respect to the origin, and the correct answer is C. For this graph, by taking 2 points 2 and 8, 1 and 1, and by searching for the opposite values of these points, you can see that for 1 and 1 we get negative 1 and negative 1. For 2 and 8 we get negative 2 and negative 8. So each value of x have the opposite value on the other side of the graph. For 2 we have minus 2. For 1 we have minus 1. And each value of y, which is 8, have the opposite value on the other side of the graph, which is negative 8. For 1, we have negative 1. So this means that the graph is symmetric with respect to the origin. And the correct answer is C. Again, for this graph, by taking this point A and B and another point minus A and minus B, here the value of x and y, and on the other side of the graph we had the negative x and negative y, or the opposite values of the negative values of the points. So this means that this means that the graph is symmetric with respect to the origin. So the correct answer is C. For this graph, by taking a point A and B, or x and y here, and another point on the other side of the graph, you can find that we have negative x and y. And negative x means this is symmetric with respect to y-axis. But if we have the negative y, this means this is symmetric to the x-axis. If we have the negative values of x and y, this means that the graph is symmetric with respect to the origin. In this case, or in this graph, we only get the value of the negative x. So this is symmetric with respect to y-axis. And the correct answer is B. another graph by taking different points 3 and 4. This is x and y, and on the other side minus x and y only, and this means this is symmetric with respect to y, or another values x and y, and on the other side negative x and y. And this means this is symmetric with respect to y-axis, and the correct answer is B. True or false? Determine if the following statement is true or false. The equation is symmetric with respect to x-axis if the value of it unchanged by replacing x with negative x. Here we are asking about the symmetry with respect to x-axis, so we need to change the value of y, not x. So if the value of the equation is unchanged by replacing y with negative y, this would be symmetric with respect to x-axis. But here in this statement, he's replacing the value of x with negative x, which is not true with the x-axis. So this statement is false. Question 2. The equation is not symmetric with respect to x-axis if the value of it is changed by replacing x with negative x. This is also false, as by testing symmetry with respect to x-axis, we change the value of y, not the value of x. Question 3. The equation is symmetric with respect to x-axis if the value of the function is unchanged by replacing y with negative y. This is true. As for testing symmetry with respect to x-axis, we change the value of y with negative y, and if the value of the equation unchanged, so it's symmetric. So this is true. Question 4. The equation is not symmetric with respect to x-axis if the value is unchanged by replacing y with negative y. This is false, because in this case the function would be symmetry, not symmetric. So this is false. Question 5. The equation is not symmetric with respect to x-axis, not symmetric for y-axis, sorry, if the value is changed by replacing x with negative x. This is true. As for testing the symmetry of a y-axis, we change the value of x with negative x. And when we change the value of x with negative x and the value of the equation changed, so this function is not symmetry. So this is true. The equation is symmetric with respect to y-axis if the value of it is changed by replacing y with negative y. This is false, because when testing symmetry with respect to y-axis, we change the value of x, not y. So this is false. Question 7. The equation is not symmetry with the origin if the value is changed by replacing negative y with y and negative x with x. Here in this question, he's asking about the symmetry with respect to the origin, and in testing this, we change the value of x with negative x and y with negative y, and if the value changed, so it's not symmetry, and in this case this statement is true. Thank you for watching this video and sharing your time with us. Hope it's useful to you. See you at the next video. Good luck to you all, and goodbye.